In a remote area, workers are performing an incredible feat welding broken train tracks using a traditional method known as aluminothermic welding. First, they clean and align the broken ends of the track, lifting them at an angle and measuring with a metal ruler. This helps manage the heat expansion and contraction during the welding process to keep the track flat once it cools down. Next, they place heat-resistant graphite molds on either side of the brake, sealing the gaps with heat-resistant clay to prevent molten steel from spilling out. With everything in place, they begin heating the track in molds to reduce the temperature difference between the steel and welding material. On the other side, the workers mix aluminum powder and iron oxide to create the aluminothermic mixture. They load it into a furnace-like pot, then ignite it with a match. The chemical reaction kicks off, sending temperatures soaring to over 1000 C, melting the metal. The molten metal flows into the mold's iron. Being denser, fills the mold first, while the lighter aluminum flows into the sides. Once the pouring is done, the workers quickly remove the molds while the metal is still hot, using hydraulic equipment to push the two track pieces together. They smooth out the joint and remove any excess material, leaving behind a perfectly welded track. This method brings two broken pieces of track back together, ready to carry trains again.